Hello, my dear students. Good morning, everyone. How are you? Hope you all are very fine, well, and safe in home. This is your Chemistry 1 class. In last class, we had learned about spectrum of hydrogen. Today, in this class, I am going to solve some problems on hydrogen spectrum. Dear students, while learning spectrum of hydrogen, we had learned an equation, Rydberg equation. Have you remembered this equation? Today, for doing the math of spectrum of hydrogen, we need this equation. We have to get clear idea about all the terms of this equation. The Rydberg equation is a mathematical formula used to predict the wavelength of light resulting from an electron moving between energy levels of an atom. The equation is nu bar equal 1 by lambda equal RH into Z square into 1 by N1 square minus 1 by N2 square. Dear students, here nu bar is the wave number and lambda is wavelength. You know that wave number and wavelength are proportionally inverse to one another. Here, nu bar is wave number, lambda is wavelength, R is equal Rydberg constant. It has a constant value that is 1.09678 into 10 to the power 7 meter inverse. Z is atomic number. When you will explain the spectrum of hydrogen or when you will do the math on spectrum of hydrogen, that time no need to use this Z square because the atomic number of Z is 1. So if you omit this Z square, then there will be no problem or there will no effect for the result. But for other atom or ion like helium ion, lithium 2 plus ion, you need this Z square. Here N1 is the lower energy level and N2 is the higher energy level. Now, in your book, there are some math done in example and also there are some exercise in your book. From there, here I will solve some problems from your book exercise. At first, problem 2.33. What is the largest wavelength line in nanometer in infrared series for hydrogen spectrum where N1 equal 3? You have to find out the wavelength of a spectrum series. Here N1 equal 3, but the value of N2 is not given. But what is telling there? You have to find out the largest wavelength line. Largest wavelength line means what? The spectrum line which has smallest wave number because wavelength and wave number are proportionally inverse. Now, largest wavelength or smallest wave number will form when the electron jumps back from very near. Here, the electron jumps back on third shell because N1 equal 3. So, it is the lower shell. So, upper shell will be very near of third shell. Which shell is very near upper shell of third shell? Obviously, fourth shell. So, N2 will be what? N2 will be 4. Now, dear students, if there is given N1 equal 1, then what will be the value of N2? It will be 2 because second shell is very near to first shell. If N1 is 2, then N2 will be 3. If N1 is 4, then N2 will be 5 in this way. Now, if it was given that you have to find out the shortest wavelength line, it is the largest wavelength line. For shortest wavelength line, there will be more wave number. So, the electron has to come from very far of third shell. Which shell is very far of third shell? Fourth shell, fifth shell, sixth shell, or seventh shell? No, it is very far. That means N2 will be infinity. Dear students, here for the largest wavelength line, if N1 is 3, then you have to put N2 equal 4, very near of third shell. And for the shortest wavelength line, whatever N1 equal 1, 2, 3, 4, 5, 6 or anything, N2 will be always infinity from very far from the shell. So there is given N1 equal 3, N2 equal 4 and Rydberg constant Ra is equal 1.09678 into 10 to the power 7 meter inverse. Here we need to use Rydberg equation because here all the values are given. If we use Rydberg equation, we can find out wave number and wavelength from there. Here Rydberg equation, nu bar equal 1 by lambda equal Rs into 1 by N1 square minus 1 by N2 square. Dear students, look, there is not given Z square. If you give here Z square, then there will be no problem. But this is hydrogen spectrum, so no need to use Z square here. Now after putting all these values, we get nu bar equal 0.0533 into 10 to the power 7 meter inverse. So lambda equal what? If you inverse it, then lambda equal 18.756 into 10 to the power minus 7 meter. Now you have to find out the wavelength line in nanometer. So 1 meter equal 10 to the power 9 nanometer. So if you multiply this by 10 to the power 9, you will get the wavelength in nanometer. After multiplying it by 10 to the power 9, we get lambda equal 1876 nanometer. This is our required answer. Now another one, problem 2.35b. The excited electron of hydrogen atom jumps from N shell to L shell of hydrogen atom. Calculate the wavelength of the photon energy. What will be color of spectrum and name of spectrum series? Dear students, look here, the same type of math. Here the electron of hydrogen atom jumps from N shell to L shell. That means fourth shell to second shell. Here you have to calculate the wavelength of the photon energy and also the color of spectrum and name of spectrum series. Here there is given N1 equal lower energy level, that is L shell, that is N1 equal 2. N2 equal N shell, N2 equal 4. Here Ra is you know. Here also we will use the Rydberg equation and we will calculate the wavelength of this spectrum as same as before. Here by putting all these values, we get wave number nu bar equal 0.2056 into 10 to the power 7 meter inverse. Now we get lambda equal 4.86 into 10 to the power minus 7 meter. Dear students, if you keep it in meter, then it is also correct. But here we have to find out the color of the spectrum, and to find out the color of the spectrum, we should convert the wavelength in nanometer. So we get lambda equal 486 nanometer. Now, dear students, look, the wavelength of visible light lies between 380 nanometer to 780 nanometer. So 486 nanometer belongs to in this wavelength line, and 486 nanometer belongs in which color? We know the range of wavelength of blue color is 450 to 500 nanometer. So the color of spectrum is blue because 486 nanometer belongs to in this range in blue colored wavelength. So the spectrum is blue. Now our third question is, what is the name of spectrum series? Spectrum series means it is in Lyman series, Palmer series, Paschen series, Brackett series or Fund series. Dear students, look, we know from hydrogen spectrum that if N1 is 1, then the spectrum line will be in Lyman series. If N1 is 2, then it is in Balmer series. If N1 is 3, then it is Paschen series. N1 is 4, it Brackett series, in this way. Here, look, the value of N1 is 2. So, the spectrum line will be in which series? Obviously, it will be in Balmer series. This is our third answer. So, there are 3 questions and the wavelength is 486 nanometer. The spectrum color is blue and it is in Balmer series. Now, another problem 2.35D. The excited electron of helium ion jumps down from 4th energy level, creating the line spectrum in Lyman series. Then calculate the wave number and wavelength of the radiated rays. Dear students, look, the excited electron of helium ion, this is not the electron of hydrogen atom. Here there is given, there is helium ion and it jumps down from 4th energy level. But there is not given the lower energy level. But there is telling that the spectrum line is created in Lyman series. Lyman series means the value of N1 equal 1. So, here the value of N2 is 4 and the value of N1 is 1 because the spectrum line is created in Lyman series. You have to calculate the wave number and wavelength of this radiated ray. Here N1 equal 1, N2 equal 4 and Z equal what? Z equal 2 because it is helium ion. Its atomic number is 2. R is Rydberg constant, you know. Here also we will use the Rydberg equation and by putting all these values we can calculate the value of wave number and also wavelength. So now put all the values and we get wave number nu bar equal 4.1129 into 10 to the power 7 meter inverse. This is our first answer. And now you have to calculate the wavelength of the ray. Here we get lambda equal 24.31 into 10 to the power minus 9 meter. You can keep this wavelength in meter and also you can convert it into nanometer. So after converting it into nanometer, we get wavelength equal 24.31 nanometer. This 2 is our answer. Now, another problem 2.35E. The excited electron of hydrogen atom jumps from K shell to M shell. Calculate the absorbed energy first and then calculate its frequency. Dear students, look, here the excited electron of hydrogen atom jumps from lower shell to upper shell. So, obviously it will absorb some energy. here you have to calculate the absorbed energy. Now, to calculate energy, you can use Rydberg equation also. By using Rydberg equation, you can find out the value of wavelength, and from this wavelength, you can find out frequency, and then by using this frequency, by using formula E equal h nu, you can calculate the energy of the radiated ray. But there is telling that calculate the absorbed energy first and then calculate its frequency. That means you cannot calculate the frequency at first. You have to calculate the energy at first, and then by using energy, you have to calculate its frequency. So, dear students, in previous class, we learned to find out the energy by using another formula. Did you remember this formula? This is the formula. By using this formula, we can calculate the energy of any orbit. Here, energy of electron in nth orbit, En equal minus 2 pi square me4 divided by h square into z square by n square. Here, m equal mass of electron, E equal charge of electron, h is Planck's constant, and z is atomic number, and n is the shell number. So by using this formula, we can calculate the energy of any shell. So by using this formula, we can calculate the energy of K shell and M shell also. And when electron jumps from K shell to M shell, the electron will absorb some definite amount of energy. And the value of this energy will be the difference of energy of these two shells. So, after calculating the energy of both shells, if we subtract the energy, then we can get the absorbed energy of electron. So, here by using this formula, we will calculate the energy of K shell and M shell. But here, to calculate the energy, no need to put all these values. We can memorize the value of this full term, and by using this value, we can calculate the energy. There is given this, the value of this full term minus 2 pi square me4 divided by h square equal minus 2.18 into 10 to the power minus 18 joule. And also here N1, that means K shell, this is 1, into M shell, this is 3, and Z equal 1 because this is hydrogen atom. And the energy of electron in K shell E1 equal, now we will put this value because the value of this full term is minus 2.18 into 10 to the power minus 18 joule, and by putting the value of Z and N, we get the energy of K shell equal minus 2.18 into 10 to the power minus 18 joule. In the same way, we will calculate the energy of electron in M shell, and the energy we get, the energy of M shell equal minus 2.18 minus 2.18 into 10 to the power minus 18 into Z square by N square joule, and by putting these values, we get energy of electron of M shell equal minus 2.422 into 10 to the power minus 19 joule. Now we get the energy of K shell and also M shell. So by subtracting the energy of these two shells, we get the absorbed energy of electron. So the absorbed energy equal E2 minus E1 equal 1.9378 into 10 to the power minus 18 joule. We get the energy. Now by using this energy, we can calculate the frequency of the electron. Here, there we get energy equal 1.9378 into 10 to the power minus 18 joule. Is Planck's constant equal 6.626 into 10 to the power minus 34 joule second. And the formula E equal H nu. So nu equal E by H. By putting the value of E and H, we get nu equal 2.925 into 10 to the power 15 second inverse. This is our required answer. Now, dear students, there is another math that is not from your book. The excited electron of hydrogen atom jumps from N shell to L shell of hydrogen atom. Calculate the energy of the radiated ray. Dear students, look, here also just like before, you have to calculate the energy of the radiated ray. So, here there is not given that by using frequency, you cannot find out the energy. So, you can use any formula. You can do the math by using the formula of previous math, and you can also use Rydberg equation. From Rydberg equation, you can calculate the wavelength and frequency, and by using this frequency, you can calculate the energy. So, here I will solve the math by using Rydberg equation. Here there is given N1 equal 2 and N2 equal 4. Here Rydberg constant you know, and we need the value of C, that means velocity of light, and also value of H, that is Planck's constant. All these values are known to you. So we will put the Rydberg equation, and by putting all these values, we can calculate the wave number and wavelength from there. We get wave number equal 0.2056 into 10 to the power 7 meter inverse, and wavelength equal 4.86 into 10 to the power minus 7 meter. Now, dear students, I told that E equal what? E equal H nu or H C by lambda. So here, by putting these values, we can calculate the energy. Here, by putting all these values, we got energy E equal 4.09 into 10 to the power minus 19 joule. This is our required answer. I am telling again, you can do the math by using previous formula also. That means you can calculate the energy of N shell and L shell, and from there you can calculate the energy of the radiated ray. So, dear students, today up to this, in your book there are also some math. You will solve this math, and I will give you some homework also. There are 2 math as your homework. You will do these 2 math in home, and you will submit this homework in my personal ID by Monday. So, today up to this, thank you everyone. Dear students, goodbye to all.